Cool, thanks. All right, hi everyone. Thanks for having me here, first of all. Awesome to be back in Berlin. Haven't been here in a while. And yeah, so today I want to talk to you more about sort of like the application layer and how they are building the next generation of decentralized applications in Web3. Specifically, I want to talk about sort of autonomous cross-chain dApps, how I like to call them. And these applications that are interacting with different instances of each other via cross-chain messaging protocols, but in a completely autonomous fashion, so users don't actually have to instantiate any of these messaging between applications. And I have a case study that I would like to present to you today. This is actually just a real-life case study of one of our users of a protocol called Abracadabra. I discovered this case study by just having a chat with the lead engineer, and he showed it to me, and I just want to show it to you guys because I think it's quite interesting. And before that, I will just quickly touch upon sort of like the evolution of sort of like applications and multi-chain applications, how we got to where we are today. Then I go into the case study, show you how they actually do it, and then very briefly touch upon sort of like some next cool things that are coming up for building multi-chain applications in Web3. So, regarding the evolution of multi-chain applications, I think you all remember so like this user interface, right? It's the traditional Uniswap v2 interface that we had, very like simpler times back then, right? We had like one chain, we have one application, one front end. We didn't have like 8 different chains with the same contract on there and 8 applications and wallets we had to use. So very simple times back then, and the stack was sort of like just like monolithic if you think about it. Then we entered sort of like the fork era where we had networks like -Marchain come out, Polygon come out, and a lot of different ones, and they basically, the sort of like applications on Ethereum weren't really like ready to embrace multi-chain. So basically other people came, took the applications, deployed sort of like the same contract with the same naming usually, just on a new network. And what you basically ended up with, you had like these two pillars next to each other with like 2 different front ends, 2 different, like the same user wallet, but like having to be connected to different networks, and then 2 different instances of the same sort of application, but actually not even controlled by the same team on 2 separate sort of applications. Then I think a lot of projects actually realized this sort of transition to the multi-chain movement, and they adapted, right? And rather than saying, hey, I just deploy on one network because I'm like a maxi of that network, I want to just enable everyone in the whole ecosystem to use my application. So that's why you had a lot of applications, including for example, ours, Gelato, go completely multi-chain. We are, for example, now on 9 different networks. You see this very, very long network tab. I think there are like 9 different chains and 5 different test nets on there, and it's just getting longer and it's terrible, and I want to get rid of it at some point and just throw it out. But yeah, this is just where we are right now, so like in a stage. 10 different networks you have to connect to, but you have one sort of UI that connects to all the different instances, but they live in their isolated sort of hierarchies, right? And now what sort of like the next movement was, especially with the proliferation of bridges and everything, and this is an example of a sort of like a bridging network called Connex, where you actually had users that can come to your application and they can come in on one front end, and they can connect to one particular wallet on one particular network they want to be at. Let's say they're on Polygon, right? And then they can interact with this instance of your system on Polygon, and by sending a transaction, the contract from Polygon then emits an event, which then triggers a cross-chain messaging, a cross-chain message to, let's say, Phantom, for example, to tell some nodes to, hey, bridge some assets, for example. So you can actually interact as a user with a contract of another network without actually having to sort of connect to that network, right? So it's getting abstracted from it. And there are like relayers and stuff in the background that facilitate that, but this is sort of like the where we are right now, especially with like bridges and stuff. And now, so like the next evolution of that, which I think quite interesting, and that's what I wanted to like show you, how projects like Abracadabra, for example, are doing this, is actually having a completely autonomous cross-chain user experience. So actually users don't have to send transactions anymore that then trigger asynchronous cross-chain messages to other chains, and then they have to wait 5-10 minutes to then get a message back or something and then do something. Actually, the applications themselves have certain recurring processes in place that sync the state between different chains every couple of minutes. So you can only interact with one chain, and you can get what you want out of it right away without having to do this, without having to wait until this cross-chain message is relayed, for example, and it sometimes takes 15 minutes, 20 minutes, for example, right? So this is what I want to show you, how this is done by Abracadabra. And I'm not affiliated with Abracadabra whatsoever, but they are just using our protocol. But they definitely have a cool team. And basically what they do, they're sort of like a MakerDAO, but on all the other chains. You can think about it. You can put in collateral, and then you can mint a stablecoin called MIM. And with that stablecoin, yeah, you have a stablecoin. You can do whatever you want, leverage or whatnot. And basically what they wanted to do, or what they actually did, is they wanted to automate the payouts of their staking rewards within their system cross-chain completely autonomously without having the users request each individual reward from mainnet in like a asynchronous fashion where they have to wait until they actually receive the funds, right? And so how it works, they have their native governance token called Spell. You can stake that Spell on, you can stake it on Polygon, you can stake it on Ethereum, on Avalanche, wherever you want to. And once you stake it, you have access to, I think, weekly sort of emissions of MIM rewards, right? And there are, let's say, 1 million MIM being paid out every week to all the stakers, right? And so like the contract that mints this new MIM, it's located on Ethereum, but you can stake your Spell on all the other chains, right? Because maybe you are like a Polygon native user, you're only on Polygon, and so you obviously only stake your Spell there. You don't want to interact with like mainnet and encounter the gas fees. And so what is happening here is that of course, Ethereum doesn't know how many people staked on Avalanche or how many people stake on Polygon, for example, right? So Ethereum needs to know this, so Ethereum knows, okay, how much, let's say, if 10% of all the Spell was staked on Polygon, Ethereum needs to know that every week it has to send 10% of all the rewards to a contract on Polygon, where then the people can actually withdraw these rewards, right? But in order to not have each user get their own sort of funds every week from mainnet and incur the gas costs, they want to like aggregate it and make this completely an autonomous process running in the background that no one can basically stop. And so there are two components you need in order to achieve that. First of all, the cross-chain messaging protocol. This is sort of relevant, I think, for the Oracle Summit because I see them sort of as like Oracle networks. They basically tell a chain what the state or what the payload, or they tell one chain what another chain wants to send to them, right? And you have to sort of like trust this trust assumption or the trust model that this cross-chain messaging protocol brings to you, and then what you can do is you can interact from Polygon, in this case, to Ethereum and back, right? This is what they enable, and there are a couple of examples of prominent cross-chain messaging protocols. There are a bunch of more ones, right? But these are just like 3 examples that I have sort of like interacted with myself in the past, and yeah, they have all of they are sort of like, they have their pros and cons. They're all sort of like you can think about them as an Oracle network, just with like different trust assumptions. Layer 0, for example, is sort of like, hey, you can pick and choose your own trust assumptions. You can sort of like pick your own Oracle. And as long as you believe that the Oracle, and they have like a relay in the system, as long as you think this Oracle is actually posting the correct block hashes of the sender chain onto the receiver chain, then you are sort of like trustless, and it works nicely, right? Whereas with something like Nomad, for example, they have this what is called an optimistic fraud proof, where you actually have like this optimistic delay of 30 minutes. Before your transaction will actually get executed on the receiving chain. And in that 30 minutes, anyone in the world can come in and prove, hey, someone actually, this transaction that will go on in 30 minutes is actually wrong, it's faulty, it shouldn't be executed, and you can come in and prove that and stop the whole system. So it has this sort of like nice optimistic fraud proof, and then you have like these trusted sort of third-party, multi-party computation systems, like for example, multi-chain, and there it's you trust basically that their validator set is not malicious and they don't collude. Cool thing is for the sort of like more layer 0s and multi-chain, which for example I would assume like multi-chain could also be used on layer 0 as an Oracle at some point, but they are very fast, whereas like a Nomad, which is a bit more secure because they provide this optimistic delay, it's unfortunately a bit slower. don't want to go too deep into the cost, but the more sort of you do off-chain and the less you have to check and validate on-chain, obviously the less expensive it gets and the more it scales nicely. Yeah, from the fraud protection point of view, Nomad is sort of like the only one here to provide something, but it's basically, I believe, regarding cross-chain messaging protocols, it sort of depends on what you like. Do you like speed? Do you like cheap costs? Or do you really want high security because you move like large amounts of funds? And you should be able to like pick and choose which one is the best. So yeah, we actually have a system where we sort of like have like an aggregation layer of like different cross-chain messaging protocols, and we can just, for the use case we want to use, pick and choose the right one, and then yeah. It's basically what you want to do. And then the second thing you need to sort of like create these autonomous syncing processes around these chains is like a job scheduler application, for example, like a Gelato, or what we are building. And basically what we do is we just enable you to automate certain executions of processes. Basically you can define functions, and then you can define when these functions should be called, under which conditions, and then Gelato build a decentralized network of executor operators, and they just execute it for you, and then you can automate these payouts. And if you combine that with like a cross-chain messaging protocol, you can automate these processes across different chains and have the feeling of having one chain, one application, but actually there are like multiples in the background, which is quite cool. These are just a couple of examples of projects using it today, from like rebasing currencies to padding NFTs every 8 hours or whatever, like fun little apps. Yeah, so to the case study now. This is sort of like the architecture. I like to call it like a hub and spoke model that they're using. So they have one hub, which is Ethereum. This is where all the data has been stored and aggregated. So this is where they need to know how much spell was staked on all these little spoke chains. And spoke chains are, for example, Polygon or Avalanche. And the first thing they actually want to do is, okay, every day, and they actually have like a modifier in their smart contract called only noon. So every day or every week, whatever frequency you want, at noon, please call a specific function, which is the send amount function, on one of these mspell reporter smart contracts on one of these spoke chains. And what these functions do is basically they send they sort of like query how much balance you have, and then they send a cross-chain message, in this case via layer 0, to Ethereum to let Ethereum know how much was staked in all these networks. And this is actually, I hope you can see that from like a size. I can also make it bigger, but I think it's fine. This is sort of like the function here. And what they do is they basically, this is the juicy bit, they just basically query, hey, what's the balance of this particular contract? And this is a contract on Polygon, for example. What is the balance of spell in here, right? And then they basically send this information, this payload, via the cross-chain messaging protocol layer 0 here to the mspell sender smart contract, which lives on Ethereum in this case. And they have this LZ receive fallback function that is being called by layer 0. And here they basically decode it, and then they store in state basically, hey, this is the amount staked on this particular network, and this is the time when this was last updated, right? So this is sort of like the first process, and this gets basically triggered every couple of hours by Gelato in the background, and then on all different chains, and all these chains send these messages, right? And so you are syncing basically the state of your applications every couple of hours, and you can of course increase the frequency as you want. The cheaper transaction fees, the more frequent you can do these things. And then you have the second task, and this is actually initiated on the other side, so on the hub, in this case Ethereum. And this is then, okay, once all of these transactions have been executed from the spoke chains, please actually trigger a transaction on the hub chain, and then send all these rewards to the respective contract addresses on the spoke chains, right? And there you have, this is basically distribute the rewards, distribute the right amount of rewards to all these chains. And this is where you have an mspell sender contract on Ethereum, and you have this bridge mim function, which is in the same contract here. This is the one we have on Ethereum, right? And this is here the bridge mim function. They have this only past noon modifier, right? So it can only be called sometime after noon. And yeah, they sort of like query what's going on, what's the total balance, and they do some decoding and blah, blah, blah. And here's then the juicy bit is basically they use, in this case, the AnySwap, or I think multi-chain called now, multi-chain router system to then, in like a for loop, send these rewards to all the specific chains. And this sort of completes this syncing of state and reward payments, payouts in this regard. And then the receiver of this message lives then again on the spoke chain, and this is the spell contract. This is just like the staking contract where you can lock it up, and then you can withdraw your rewards, and you can draw your spell again if you would like to query it back. Yeah, this is sort of like how the syncing works. And regarding sort of like the future, how I see it is that I think we will see more and more applications moving to these sort of models. I think Curve recently also transitioned to a model where they are now doing these payouts completely cross-chain. I think they're actually still doing it sort of user-initiated and not fully automated. But I would assume that a lot of applications that have these, that they need to keep track of like liquidity or need to keep track of rewards or any other sort of metric across different networks, that they basically come to a model where they're syncing these states across them, and it's sort of like these contracts on different chains feel like one machine, but they're sort of like get synced every so often. And of course, if you accept, instead of having Ethereum as the hub, use, for example, a layer 2, which maybe inherits the security of Ethereum but provides significantly cheaper cost, you can actually sync like every couple of minutes here. And this would actually be quite cool. So what I think is actually happening right now, and this is also something we are working on Gelato, is we are seeing more and more projects basically using like our service, let's say, on 8 different chains and then using these cross-chain messaging services. And the problem here is that they all have to sort of like pay for different transactions and for different relayers on like 6, 7, 8 different chains, and it's getting there's a huge operational overhead for them to do so. And what we're actually working on is sort of like a cross-chain balance system where projects, maybe at some point even users, but especially like protocols, can have like a balance of, let's say, ETH, and then with that ETH can actually pay for all these autonomous executions on a Polygon, on a Phantom, or vice versa. You can just have a balance on Polygon and you can pay for all of your transactions as a protocol that get executed by third parties, which are either cross-chain messaging protocols or job schedulers like Gelato, pay for all of these with like one simple balance on all different chains. And this will be much easier for them to maintain and operate, and this enables you to build these really like synced multi-chain applications in a much more streamlined fashion. And yeah, so this is roughly what I wanted to discuss today. Thanks for listening. If you have questions, let me know. Thanks.